Most of the time, we wish to work on primitive values rather than the references when working with streams. For example, if we wish to find out the sum of quantity for all the trays, this is what we will do. Here we have streamed the trays, fetched the quantity and reduced the quantities to a sum, a single value. Reduce is an aggregation function, a function that would accumulate all the tray quantities to produce a final sum as seen here. Did you notice a return type? Optional is a new type introduced in Java 8 to combat famous null pointer issues. We will work on optional types soon, but let's continue to work on primitive streams. The approach seems to be all okay so far, but the issue is around cost of boxing that this block of code has to incur. There is a considerable cost in conversion of primitive int to integer class and vice versa. The quantities are worked out as primitive integers, but converted to integer objects and so on behind the scenes. Designers have delivered a stream that works on primitive integers, primitive longs, and primitive doubles too. There are three specific implementations of primitive streams: an int stream, long stream, and a double stream. As the name suggests, they support the respective primitive types. Let's quickly look at int streams. We create an int stream by simply calling a static method of on the stream. The method of is an overloaded. We can either provide a set of integers or an object of integer array. This is the static of method taking all the integers, producing an int stream. Now you have int stream, you could simply use that for producing the values out. If you run the program, you see the integers produced as primitive integers printed out on the console here. We could also provide a list of integers like this. Here, the of method is considering the integers straight away rather than an object of arrays like shown earlier. Both should print out exactly the same values to the console. Of course, I missed out 10 in the second one. The same principle follows for double and long streams too. So I simply copy the code. We have here an array of doubles. So using double stream of method, we pass that array object to this method to produce a double stream. And as you can see, we are printing them out first. We also have a second of method on double stream, which takes in doubles as expected. That also produces the same double stream. Let's run this program. We produce a double stream as well. We can also convert object streams into primitive streams or vice versa. If we consider our earlier example of aggregating trade volume for a given set of trays, what we need to do is invoke the map to int method on the object stream. Let's see how we can do this here. This produces a stream of trays, and invoking map to int calling a function quantity produces an int stream. So this map to int is simply producing an int stream. We can now use a sum method exposed on the int stream to get an aggregated quantity directly. This produces an aggregated sum of all the trays of quantities. So the benefit of doing this is to avoid boxing costs. Let's wrap this session here. We learned about how we can work with primitive streams in this session. There are few methods exposed on the primitive streams API. We will run through them in coming sessions.